So we can start with some European overview of the weather situation at 6 UTC today. I think the most striking feature is the elongated dark stripe on the west in here. But I can say that other part of Europe is not so easy to analyze, but at least we can see some. Sorry, I can show you. We can see some verticity maxima on the water vapor image. If we check the infrared image, we cannot see much middle and higher level clouds. So the brightest temperature is warmer over Central Europe, and the coldest cloud top can be found in here, in the very north of Scandinavia. We can guess that it could be high-level lee clouds in the northwesterly airstream. We can check it later, maybe. So, in the middle of Europe, there is a huge anticyclone with a lot of low clouds in Central Europe, but some part of it are clear. In the very, on the high level feature, of course, it's a huge ridge in the north and south axis. Is the 500 hectopascal, so we can also view the ridge and the trough over the west and also on the east, but the eastern one is much colder. At 850 hectopascal, there are some warmer temperatures on the western flank of the ridge, the anticyclone. There is cold advection from the east, so it could be the reason for the clearing of the stratus clouds. On the night microphysical image, we also can see the low clouds, but because the sun is rising, we cannot see much on the east. After the sunrise, of course, we can see the clear or mostly clear Eastern Europe, but maybe one could say that above the snow surface there could be some low stratus or fog, and of course we can check it on the day microphysical channel. So it can be very the distinguish between the snow surface and the greenish low-level clouds and fog are well seen in this picture. I have a question for you. In the previous days in Central Europe and in Europe, there were a lot of low-level clouds, and I calculated the number of low-level clouds from the number of hours from the Safnocasting product, and my question is, you can guess which area or which territory experienced the most foggy weather, or where the most low-level clouds were in the previous 5 days. So you can put some sign on the map when where you can guess that there were a territory with a lot of low stratus. Please put some sign. Yeah, I can see one in the Po Valley. Others? In Germany, and generally in Central Czech Republic. Okay, yes, that's enough. So I can show you the calculation. I just integrated the number of hours from the Sassnokasting product when the cloud type was very low level cloud, and yes, Po Valley was one of the place where there were a lot of low clouds. But also in the center of Spain, it's a nice valley fog could be seen. We can zoom it a little bit to Po Valley, but you can see some strange pixels, which obviously this is Lake Balaton, so there are some lakes which could be problematic. I don't know the reason for it. Maybe at the end one satellite expert could explain this. Also over Spain there are small pixels which showed low level stratus, but in the reality it's just lakes. That picture, actually, it is not an MSG picture, but a nighttime image, but with a visible channel. The satellite is Suomi MPP. It's a Viers image. It's called a day and night band. So we can see the reflected moon light from the clouds and, of course, from the snow surface. And next to it, you can see the light pollution shining through the clouds, like in Prague or Budapest or in the Po Valley. I think it's Milan. And I took this picture yesterday late evening from the mountain. So also you can see the reflected moonlight from the fog in here. If we check the METALARM page, we could see some yellow warnings for fog, but on the southeast part of Europe there are some orange, and it's time to take the microphone to my colleague Andre.
Okay, hello? Now you can hear me. Okay,
yes, we can hear you. We can hear you.
I clicked in, but I think it was wrong. Sorry. So we will analyze the synoptic situation at first with the method of quasi-geostrophic diagnostics and Q vectors, and the second method, which will be the method of the potential vorticity. Both are quite popular in synoptic meteorology. So when we go further, so here where we could see this deep trough, so we can see also some Q vectors here. Some Q vector fields, and what are the fields here in red or blue? So these are fields of the Q vector divergence. Now the theory says that we can find these areas with Q vector divergence or Q vector in baroclinic zones. And the Q vector represents some kind of geostrophic perturbation, which then induces some circulation across the frontal zone. And this then causes either frontogenesis or frontolysis. Now, where we can see frontogenesis is there where the Q vector points toward the warm RMS. And this is exactly in this region. I already clicked on it, so once more I point here, so somewhere here in Spain, and you can see that here the Q vector really points toward the warm RMS, which is, so the warm RMS is somewhere, let's say here. And also what can we see from the calculations, that there is also the convergence of this Q vector. So there we should expect some upward vertical motions, and when we go to the next slide, so here you can see it together with the infrared imagery from EUMeTrain. So you can see that here is also a lot of cloudiness, also some high cloudiness. And when we go to the model forecast, so you can see that also there was some forecast the upward vertical motion here in the area of Spain. So this is also the first approach. The second approach is the use of potential vorticity fields. And this is also popular because you can quite well combine the potential vorticity with satellite images, either with water vapor images, also with the composite IRMS RGB images. So here what you can see is the so-called IRMS RGB satellite image. So what you can see that there are some greenish fields. So I will highlight them like that. So this greenish area is a warm IRMS. It's usually green because this is a subtropical IRMS, which is poor on the ozone. And there are some blue and reddish colors here, for instance. And these highlight the cold IRMS, which is going down toward the area of Spain and Portugal. And these cold IRMSs, you can see here, this is with these yellow lines here. So this is the so-called anomaly of the potential vorticity. So this is the area where there are high values of potential vorticity, and usually, so this is already some area of stratospheric origin, where there is also the height of the tropopause is quite low here in these areas. Now we can try to do also some cross-section through the potential vorticity field, and there we will see better these anomalies in this cross-section. So here, so what you can see in color, so this is a field of the potential vorticity. So the areas with high potential vorticity are here. So this is already the stratosphere. This is the area where the static stability is very high. So this is very stable air and usually also very dry. And so this dryness also appears in the satellite images, in water vapor images, for instance. What you can see here are lines, isolines. These demonstrate the potential temperature. So these are the isentropes. Now my question is that where you would expect that there should be some upward vertical motion, so some ascending motions. If you can mark it on this image, please. So no guess? Yeah, something if I would see, yes. Okay, I think that this is enough. And we can look the next slide. And on the next slide, this reddish area, but also this yellowish areas show that there are the vertical motions. So they are really on the front side of this PV anomaly. So it is over the Spain somewhere. So here you can see here. Here is Spain in this cross section. And if we go a bit forward in time, so this should be around 12 UTC, so now, but this is a forecast of the model. So you can see that there are already some PV anomalies also at low levels here, and these are already non-adiabatic. So that means that there already should be some precipitation, and there you can observe then such kind of anomalies also at low levels. And this can be also a signature of such processes like cyclogenesis, or usually such higher low level anomalies appear if there is already some kind of cutoff law, so the PV anomalies becomes isolated later in time. And there are some indices that this will really happen in the next days. So you can see here forecast of precipitation, and there is quite a lot of precipitation here in this eastern part of Spain, in this region. Also, if we would look at the extreme forecast index, so one can see that this is already climatologically significant, this amount of rain. So this was about this part concerning the fronts and the large-scale synoptic motions. But with approaching of fronts and troughs, one can also expect some convection, mostly in the warm air mass. And we can see that here in the Mediterranean, there is quite a lot of precipitable water. Also, we see that yes, there is quite a lot of moisture. So this air mass is also relatively moist. And if we look at the equivalent potential temperature, so we can observe there some kind of warm conveyor belt here. So there is a moist and warm air which is going from somewhere here from the region of Africa up to the France, and really some thunderstorms that were observed already this morning. Now, if we look at the buoyancy distribution and the cape from the model, so we can see that yes, there is some cape, but although not very high. This region, also here, this is from another model from GFS, and definitely the model also predicts some convective precipitation in these regions where we have found this warm conveyor belt, but also in the trough over Portugal or Spain. Now, if we look to the map of lapse rate, so we can see a picture which is not very surprising, because we can see that there is a unstable air mass somewhere here in the cyclonic part, and rather stable air mass is here, where we could see that there are anticyclonic regions. But this is for the low levels, or partially also for the mid levels. And now the question is, I will erase these annotations. Now the question is for you, that what do you think that where you could find the largest lapse rate in the levels above, so rather in the mid and upper levels? So what do you think? So we have already some first guess. Can still wait some seconds. Okay, thank you. I think it is enough. Yes, thank you. And I think that so we can go to the next slide, and I will again Kornél will continue with the first explanation. So I will show the result here.
So you can see that there are large values along this stripe, and maybe we can explain it with some isentrope analysis. I don't know if you are all familiar with it, but in this picture, Andre, you should turn your microphone off. Okay. Yeah, it's better. So, so you can see the 300 Kelvin isentrope layer pressure fields. So and on the map also, not the trajectories, but not trajectory, but streamlines, sorry. And it's the European view, but if we check zoom with Central Europe, it may be much easier to see the streamlines along pressure values. And please put your sign if we please guess where are upward motion and where are downward motion in this isentrope map. You can put some text. Yes, somebody put some sign in here. Actually, there is one interesting place and there is another. Yeah, actually, in this place, we can see that streamlines go from higher pressure to lower pressure area, so it must be upward motion. But from here, above Czech Republic, the air is moving downward because it moves from lower pressure to higher pressure. And if we check the water vapor image, we can see that along the upward motion, there are much colder temperatures, so moisture and clouds are developing here. But in here, because of the downward motion, the air is drier and drier. And it could explain if we have a long time and deep downward motion along above an anticyclone, above the inversion, it can be a quite steep lapse rate, but of course, it is dry air because the downward motion also advects low humidity downward. Actually, it's the last slide of our presentation. You can see me in this picture yesterday evening. This place, under the fog, there is the river Danube. Thank you very much for your attention.